In the vast silence of space sometimes, we hear whispers, strange signals that defy explanation captured by our most advanced telescopes. Are they natural? Are they messages? Or something far beyond our understanding? Today, we uncover the most mysterious signals ever detected from space. For decades, scientists have scanned the skies for radio waves, hoping to understand the universe and maybe even find evidence of intelligent life. Most signals come from stars, pulsars, or galaxies, but a handful stand out. Signals so unusual they spark debates that continue to this day. In the quiet heartland of Ohio, a colossal instrument known as the Big Ear spent its nights listening to the silent symphony of the cosmos. Operated by Ohio State University, it was a key player in the nascent search for extraterrestrial intelligence, or SETI. For years, its work was a patient, methodical scan of the heavens, translating cosmic whispers into endless streams of computer data, hoping for one anomalous note. Then, on the night of August 15, 1977, the Big Ear heard something extraordinary. For a fleeting 72 seconds, the exact time it took for the Earth's rotation to sweep the telescope's gaze across a fixed point in space, it recorded a powerful narrowband radio signal. The signal was 30 times stronger than the ambient background noise of deep space, a sudden, unambiguous shout in the cosmic darkness. What made it truly astonishing was its frequency. It was detected at 1420 MHz, the so-called hydrogen line. This is the natural frequency emitted by hydrogen, the most abundant element in the universe. Scientists had long theorized that if an intelligent civilization wanted to create a universal hailing frequency to announce their presence, the hydrogen line would be the most logical choice. It was the cosmic equivalent of a lighthouse cutting through the fog. The signal went unnoticed for several days, buried in reams of printouts. It was volunteer astronomer Dr. Jerry Amon who, while reviewing the data, saw the anomaly. On a page filled with low-number characters representing background noise, a sequence jumped out: 6EQJ5. This code represented a signal that grew in intensity, peaked, and then faded, perfectly matching the profile of a celestial source passing through the Big Ear's beam. Stunned by what he was seeing, a signal that ticked every box for a potential extraterrestrial beacon, Amon grabbed a red pen, circled the sequence, and wrote a single, now famous annotation in the margin: "Wow!" The team scrambled. They immediately trained the Big Ear back on that same patch of sky in the constellation Sagittarius, hoping to hear it again. They listened, and they heard nothing. In the decades since, over 100 subsequent searches of the same region have been conducted by astronomers all over the world. The sky has remained silent. The signal was a one-time event. So what was it? Theories abound. Some have proposed it was a rare natural phenomenon like the hydrogen cloud of a passing comet, though this has been largely debunked. Others suggest it was an Earth-based signal reflecting off space debris, but the frequency was in a protected, forbidden band. To this day, the "wow" signal remains the strongest candidate for an extraterrestrial transmission ever recorded. It fits the profile of an artificial beacon almost perfectly, yet its fleeting, unrepeated nature leaves us with an unsolvable puzzle. Was it a technological glitch, a singular cosmic fluke, or was it a genuine message from another civilization? A 72-second greeting that we were lucky enough to overhear but unable to answer. In 2007, while sifting through archival data from the Parkes Radio Telescope in Australia, astronomers stumbled upon something that shouldn't exist. A signal of immense power, yet it lasted for less than 5 milliseconds. It was the first fast radio burst, a cosmic enigma that would challenge our understanding of the universe's most extreme physics. Initial skepticism was high. Was it a glitch, an error in the equipment? But as more of these phantom signals were found by telescopes around the world, a staggering reality emerged. The key to unlocking their secrets lies in a phenomenon called dispersion. As the radio waves travel through the sparse plasma of intergalactic space, higher frequency waves travel slightly faster than lower frequency ones. This causes the signal to arrive smeared across the spectrum, like a cosmic slide whistle. By measuring this delay, astronomers can calculate the vast distance the burst has traveled, confirming their extragalactic origins. And with that distance known, their true power can be calculated. It's a number that defies comprehension. In that tiny moment, A single FRB can release more energy than our sun does in an entire year, some even rivaling the output of our entire galaxy for that split second. The mystery deepened when astronomers realized not all FRBs are created equal. The vast majority are one-offs, solitary flashes from a distant galaxy, seen once and then vanishing forever. These cataclysmic events suggest a source that destroys itself in the process, a final, brilliant scream into the void. But then came the game changer, repeating FRBs. A source was discovered that flashed again and again, sometimes sporadically, sometimes in periodic cycles of activity and silence. This proved that at least some FRBs are generated by a durable object, something that can survive unleashing such titanic forces repeatedly. The hunt was on to find the culprit. The leading suspect is a type of cosmic monster known as a magnetar. These are young neutron stars with magnetic fields hundreds of trillions of times stronger than Earth's. A violent starquake on a magnetar's crust could theoretically unleash a blast of energy powerful enough to be seen across galaxies. This theory gained massive support in 2020, when a magnetar in our own Milky Way was caught emitting a burst with all the hallmarks of a nearby FRB. But magnetars may not be the whole story. Other theories for the one-off events include the collision of two neutron stars, or even a neutron star being torn apart by a black hole. And then there are the more exotic speculative ideas. Could they be the signature of evaporating primordial black holes? Or the snapping of cosmic strings left over from the Big Bang? Given their focused power, it's impossible not to wonder about more intelligent origins. While it remains pure speculation, some have proposed these could be signals from an advanced civilization, perhaps the powerful energy beams of a star-faring propulsion system. For now, fast radio bursts remain one of astronomy's most profound puzzles, a constant reminder that the universe is still full of secrets waiting to be heard. Beyond the legendary WOW signal, the cosmos has sent us other whispers that have deeply puzzled scientists. In the vast crackling noise of the universe, some signals stand out with an unnerving clarity, forcing us to ask if we're truly alone. One of the most tantalizing of these came in 2003, from the colossal Arecibo Observatory. It was named SHGB 02+14A. This faint, narrowband radio signal was detected 3 times, originating from a point in space between the constellations Pisces and Aries. What made it so compelling was its frequency, approximately 1420 megahertz. This is the famous hydrogen line, the frequency at which neutral hydrogen atoms emit radiation. Scientists have long theorized that an intelligent civilization wanting to be found might broadcast on this fundamental cosmic frequency, like a universal calling card. Even more intriguing, the signal's frequency was observed to be drifting rapidly. This is exactly what you would expect from a transmitter on a planet rotating at high speed. It was a textbook example of a promising candidate, but, like so many cosmic ghosts, after those initial detections it was never heard from again. Follow-up observations found nothing. Was it a fleeting transmission from another world, or an unknown natural phenomenon? The mystery endures. More recently, in 2019, the search for intelligence got another jolt of excitement. As part of the Breakthrough Listen project, the Parkes telescope in Australia detected a signal so promising it was given a name, Breakthrough Listen Candidate 1 or BLC-1. The signal appeared to be coming from the direction of Proxima Centauri, our closest stellar neighbor, a star known to host at least one planet in its habitable zone. Like SHGB 02+14A, BLC-1 was a narrowband signal, and it exhibited a steady frequency drift consistent with the source on an orbiting planet. For a time, it seemed this could be it, the first credible evidence of technology beyond Earth. An intense investigation began. Scientists meticulously analyzed the data, trying to rule out every possible terrestrial source. In the end, the truth was found much closer to home. The signal was traced to human-generated radio frequency interference. It was a false alarm, but an incredibly valuable one. BLC-1 served as a perfect fire drill for SETI, helping researchers refine their methods for weeding out our own technological noise from the symphony of the cosmos. Other cosmic puzzles aren't about faint whispers, but about incomprehensibly powerful shouts. Fast radio bursts, or FRBs, are millisecond-long blasts of radio waves that release more energy than our sun does in an entire day. For years, their origin was a complete mystery, with some speculating they could be evidence of advanced alien technology. Today, the leading explanation points to magnetars, a type of neutron star with an ultra-powerful magnetic field. Yet, many questions remain. Each of these strange signals, whether an enduring mystery or a solved case of interference, pushes the boundaries of our knowledge. They are the anomalies that drive science forward, forcing us to build better instruments and develop sharper techniques. They teach us to listen more carefully to the universe's natural chaos, and they keep alive the profound question: are we simply cataloging the noise, or is someone somewhere trying to get our attention? The most mysterious signals ever detected from space remind us that the universe is alive with energy, sound, and secrets. Whether they are natural phenomena or something more, each one is a message, waiting to be understood. And maybe, just maybe, one of these signals will be the first undeniable proof that we are not alone,